Hello and good morning and welcome to this video tutorial, which is a continuation of our exploration into the BGP best path selection algorithm. And this morning's video tutorial is going to be on step 3 in the BGP best path selection algorithm, which is prefer the locally originated route. Now, we have a look here at the top of the screen. You can see it says prefer the path that was locally originated via a network or aggregate BGP subcommand or through redistribution from an IGP. Now, we need to make sure that we don't confuse what's taking place in step 3 with what we see down here in step 5. Now, you'll notice that step 5 says prefer the path with the lowest origin type. So IGP is lower than EGP is lower than incomplete. And this is going to be for routing information when it's not locally originated. In other words, a better way to say that would be this is routing information that we're receiving that isn't originated locally on the router on which we are looking. And that is where step 3 comes into play. So again, this is going to be from a foreign, F-O-R, wow, E-I-G-N. This is going to be from a foreign source, and here we're talking about locally originated, right? So within the comparison, when we get to step 3, or I should say, let's take a look at step 1. If the weight is the same, and then we get to step 2, local preference is the same, then we look to check, is the route, did it originate locally on the router on which we're looking? And remember, we can tell very easily when it has because the next hop field is going to be the quad zeros. And that is what this is all about. If it's originated locally, that route is going to take preference. And so then we could stop the comparison right here at step 3. If we don't have a locally originated route that we're comparing an external one to, then we move down to step 4. Now, in step 3, it talks about there's a number of ways to originate routing information with BGP. First and foremost, we can use the network command. We could also use the aggregate address command, and we can redistribute from an IGP. And remember, when we're talking about IGPs, that includes static routes and it includes connected routes. So all of these things that we're talking about here in step 3, it's all about local origination. And so really what we're doing is we're comparing how was the routing information locally originated. And so again, step 3 seems pretty straightforward, but there are some caveats here, and I'm going to go ahead and pull up the topology here for our discussion. Now, you'll notice that I've broken it down into 2 sections. We're going to talk about default routes, right? Because when you originate a default route, there's also 3 ways to do that. But again, this is locally originated information. I'm going to walk through all 3 of these. You can do it with the default originate command, which configures a default route to be advertised to a specific neighbor on a per neighbor basis. Now, the key to remember about this default originate is that the route does not need to exist in the IGP, in the interior gateway protocols. So I don't need to have a static. I don't need to have a connected. I don't need to have something I've learned from OSPF or EIGRP or ISIS. I can simply put neighbor, 2.2.2.2 default originate, and that is going to send a default route. And we're going to see that when we're doing it with default routes, that takes precedence. The per neighbor configuration is the most preferred. So again, because remember, we're comparing the steps, step 1 weight, step 2 local preference, but within step 3, whether it was locally originated or not, as soon as we determine, yeah, it's been locally originated, then we have to continue the conversation as to how was it locally originated, because within the context of local origination, we're going to see there's 3 different ways to do the default route, and then we're going to look at the 3 locally originated non-default routes. Now, there's a reason I've broken this up into 2. First and foremost, the default routes are sort of a special circumstance when it comes to locally originating them, because there's 3 ways that we can do it. When we talk about locally originated non-default routes, there's also 3 ways to do it. You can use the network command, the redistribute command, and the aggregate address command. And I've broken it up because I'm going to pull up, and this is definitely going to fall within the fair use. I'm looking at a page here, page 25, and let me actually go back to the very top here and show you the text. So this is an amazing textbook I shouldn't say textbook, just an amazing book from Cisco called BGP Design and Implementation. Now, the copyright on this is 2004. So it's 12 years old, but there is some phenomenal information in this, and Randy Zhang and Micah Bartel did an outstanding job. But if we go back to page 25, and let me put 25 in there. Whoops, sorry about that. If we scoot back down to page 25, and it talks about the BGP best path selection algorithm. And you can see we've got weight, we've got local preference, and then we get to number 3. Right? Now, it's interesting that the Cisco document that we've referenced to this point doesn't break step 3 down like this. So let's take a look at this. It says the routes are evaluated based on the origination. And again, the bottom line is what we're saying there, right? Based on the origination is that basically you are going to prefer a route that was learned locally from a local IGP source on the router. Remember, when I say IGP, it doesn't just mean OSPF and EIGRP or ISIS. Remember, static and connected fall under that quote-unquote IGP category. So, and again, it makes complete sense that a locally configured or originated route, that source is going to be more believable, more trustworthy than something that is external, right? And again, that's what step 3 is saying is, hey, is the source locally originated or not? If they're both external, in other words, if they're both not locally originated, then we go to step 4, and that's where we take a look at the AS path. But within step 3, there's sort of, think of it as like this sort of sub-evaluation process because of the fact that there are multiple ways in which we can originate routing information, prefixes, right, or routes on a router in BGP. And it's interesting, like I said, that this little blurb here that's out of this BGP design and implementation text is you don't see this reflected in that document that we looked at. And it says, here's the complete order with decreasing preference. So again, the most preferred is going to be the default originate, and that's configured per neighbor. Then default information originate, which is another way to originate a default route. And that is not per neighbor, that is per address family. So that's going to get advertised to every eBGP peer that I've got. And then we have network, redistribute, and aggregate address. And those last 3, that's actually what the document is talking about, is the network, the redistribute, and the aggregate address. So it begs the question, why doesn't it talk about default information originate or default originate? And again, this book is 12 years old, so at the time of the writing of this text, this may have been accurate. I'm going to show you that in reality, I think maybe what they were saying here is for default routes, this would be number 1, and this would be number 2, and then these would be their own sort of non-default routing information that had been originated is then evaluated network 1, redistribute 2, aggregate address 3. And what's interesting is the default information originate is actually 3, because in between these two, we can originate the default route in OSPF with a simple network 0.0.0.0 command. Now, there are some caveats here. The default information originate and the network command both depend upon that prefix, that default route prefix, quad zeros, existing in an IGP somewhere. So again, directly connected, which it's not going to be, but static, it could be learned from an IGP. But it has to be in the router IP rib in order for the network command or the default information originate command to actually function. And I'm going to walk through both of those examples, and you'll see that it does not advertise a default route unless that default route, the quad zeros route, exists in the IP rib. And so there's a significant difference between default originate, which does not require it to exist, and these two commands here. And network is actually the second preferred way with default routing information. And so what I've done, and again, I'm not to say that this is wrong. Again, at the time, it could have been, and I can't remember 12 years ago. I can barely remember a week ago. So it could have been at the time of the writing of this text that you could not originate with the network command. Or it may be that these are out of order and network should have simply been up here between default originate and default information originate. But again, the key takeaway with step 3 is it's a very simple, on its face, it's a very simple evaluation. I've got two routes. Are they both locally originated or not? Right? And that's it. And if one's locally originated and the other one isn't, then you've got your answer right there, that the preferred path that the BGP best path selection algorithm is going to choose is going to be the locally originated path. And we'll also look at that with our redistribute, network, and aggregate address commands. So again, this is why I broke, it jumped a little bit on me, this is why I broke the drawing down for step 3, locally originated, into two categories: locally originated default routes and then locally originated non-default routes. So let's go ahead and dive in here. All of our work, whoops, didn't mean to move router 5 there. So the majority of our work is going to take place on router 5. So let's go ahead and jump on the command line here. All right, so we're on the command line of router 5, and let's do a quick show IP BGP. And again, that's the sort of old school way to do it. You can see that we have a locally originated default route in the BGP table. And how do we know it's locally originated? Well, we've got the quad zeros of the next hop. Same thing, the loopback address, quad zeros. So that is locally originated. And again, that's going to win out over a prefix that comes in, right, or a route that comes in that is not locally originated. So first of all, let me see, show run include route. Let's see, we don't have it there. What about show run section BGP? So where is it getting that locally originated default route from? Default information originate, and there it is. Let's go fix this first. Let's say router BGP 567 and address family IPv4 unicast, and we're going to say no default information originate. We're going to start with a clean slate here. And we're going to say no redistribute static. And that should do it. Let's say do show IP BGP. And there we go. So we have gotten rid of the default route that existed here first. So let's go ahead and start with a clean slate. And the first thing that we're going to do is we're going to show you what happens with the default information originate command. And that's the one that we want to start with first. Now remember, default information originate requires that it has the default route in some form on this router, or it's not going to advertise the default route. So let's prove that. And again, we're going to go over the default routes first, and then we're going to talk about network redistribute and aggregate address. So if I go into router BGP 567, and we simply say address family IPv4 unicast, and this is the command we just pulled out. If I say default information originate and hit enter, right? Let's go ahead and say do show IP BGP, and actually we can do a do clear IP BGP star, we'll say out, and then we'll say in, so we'll do a soft reconfig out and in, and then do show IP BGP. So let's take a look at the BGP local rib, or loc rib, as you'll see it referred to often. Now, we don't see the default route here. Now remember, I removed that the static, the redistribute static, which is I think is where it may have been picking it up from. So, but what you'll notice is there is no default route here. So let's go over to the neighbors. Let's look at router 4. Does router 4 now see show IP BGP? Does router 4 see a default route in BGP? It doesn't. Let's make sure. Clear IP BGP star in and star out. Although in would be the one, but I'm going to clear both just to make sure. We'll cover both bases. Show IP BGP. Do I see a default route? No, I do not. And the reason that I don't, and this was the point that I was trying to drive home earlier, is that we don't see the default route being advertised to any of the neighbors, because with the default information command, the default route must be learned via redistribution, and it has to exist in the rib. So in other words, a static route and then I redistribute static has to be there, or else it's not going to work. So let's take one last look over here. Let's take a look at router 9. Let's make sure we're seeing the same thing, that it's just not some sort of an anomaly on router 4. Show IP BGP, the BGP local rib, and again, no default route, no representation of quad 0. So on router 5, we're going to go ahead and advertise it out. But before we do, we're going to take an intermediary step here to make this a little easier. In fact, to make it possible to track things. I'm going to tag these routes with some communities. Now, if I didn't tag the default, the 3 ways that we're going to do this, the default information originate, the neighbor default originate, and the network statement, if I didn't use communities, the only way that we could tell if a router was selecting a different default route through one of the different ways we're doing it would be based off the time that the route had been in the rib, the IP rib, not the BGP rib, but the IP rib. So this is going to make it a little easier for us to say, oh, hey, look, that was the default information originate, and that's how the neighbor is selecting the route, because that's how the local route is being chosen. So again, what we're going to do is we're just going to create real quickly here. We're going to say route map, and actually I'll do IP prefix list. So IP prefix list, and we'll just call it default, and we're going to say permit 0.0.0.0/0, and that is a representation of the default route. So we're going to basically match the default route inside of a route map that we're just going to simply call route map default 1 permit 10. We're going to say match IP address prefix list, and we've called it default. And when I match the default route, I'm going to go ahead and set the community. Simply for this first example we're doing here in route map 1, we're going to set the community to 1. And remember, we're doing it 3 different ways here. So we're going to say route map default 2 permit 10, and we want to match, and I can actually recover that match, and the community will set it to 2, and then we're going to say route map default 3 permit 10. If this doesn't make sense right now, hang with me, because you'll see once we get into the context of how this is going to be used, it's going to make a lot of sense. Now, it's not just enough to set the community. We need to make sure that the eBGP neighbors that we're going to be, in IGP as well, but the eBGP neighbors in this instance, 4 and 9, AS400, AS900, router 4 and router 9, who we're going to be communicating this information to, we need to tell BGP, hey, send, if I've got communities sent, you need to send the communities to these neighbors. So that's where we're going to drop back into router BGP 567, address family IPv4 unicast, and we'll say neighbor 209.165.45.4. I'm going to send communities. Now I have a choice. I can send standard, and these are standard communities, right? Or I could send extended, or I could send both. Well, I'll just simply use both. It's not going to hurt anything. And then we're going to do the same thing for 59.9 or router 9. So I'm going to send communities, send both communities, both standard and extended, even though we're using standard here. I'll just go ahead and say both. And now those communities, when I tag the prefixes, when they're in the BGP, or I should say, when they're in the adjacency, the BGP adjacent out, right? Before they go out, they're going to be processed, and we're going to make sure they get processed by these route maps. All right, so let's say do show run section BGP. So here's what we have so far. So now we're going to change things a bit. I'm going to say default information originate, and you'll notice that there's really no way for me to apply the route map. Well, that's because the route map application is going to be when I redistribute, because remember, default information originate has to have the default route redistributed into BGP so that this is going to work. So let's go ahead and set our default route up. So I'll just say IP route quad zeros, and we'll just send it to, I could go FA00, so we'll just say null 0, right? I'm just going to send it to the bit bucket. Now, let's get back into router BGP 567, and we're going to say redistribute static, because that is a static route, and now I can apply my route map. And so we're going to use default 1. So the community 1 is going to indicate that the default information originate statement is how we've done this. And again, I could have used any value in that route map. I could have said 100, 200, 300 for the values. But again, there's no need. We're just going to keep it simple. So number 1 is using default information originate. Here's my redistribute static statement, which is going to tag or label this version of the default route, right? This local origination method we're using is going to have its default route labeled with a community tag of 1. And so I hit enter, redistribute static, map default 1, and let's see, did it pick it up over here, or are we going to have to give router 5 a little show IP BGP, give router 5 a little kick, and there it is. So as soon as we put the redistribute statement into play, redistribute static, boom, we get the default route. So now you're probably wondering, well, where's that community value? Well, if I say show IP BGP using the old school form, there it is, community 1. So this is important. Now you should start to see some context around why I would want to tag this, because now I can identify with that show IP BGP command, which I could have said show BGP IPv4 unicast 0000 and gotten the same output. That's sort of the multi-protocol approach, the new school way to get that output, even though it's the same output. But again, we see the community value of 1. And remember that that means that router 4 has received from router 5 the default route using the default information originate method. Let's see about router 9. Let's make sure we're consistent here that both router 9 and router 4 are getting the same default route, and they are. And again, we've only configured it one way, but we're going to start to see now, as soon as I do it the second way, you're going to start to see that there is a difference between which locally generated default route on router 5 is going to be preferred. So right now, where do we stand? We have a single default route that's being sent out, and we've used the default information originate method to do that. Now what we're going to do, do show run section BGP, is for router 4, or I should say autonomous system 4, which is router 4, we're going to use the neighbor default originate statement. Now remember, if we look back at the text, it says here's a complete order with decreasing preference. Default originate, which is configured on a per neighbor basis, is going to be more preferable than default information originate. And so let's find out if that is a true statement. So we're going to go ahead and say neighbor, if I spell neighbor correctly here, neighbor 209.165.45.4. And you can see there is the, sorry about that, there is the default originate command, and conveniently I can apply a route map to this command. So let's go ahead and say route map, and again, I'm not going to apply default 1. That was for when we were using the default information originate command. I'm going to say default 2. Because default 2, that route map is going to label or tag this version of the locally originated default route with a community of 2. Now, the communities don't impact the BGP best path selection algorithm. They're just simply a convenient way for us to apply a label in the form of a community to the prefix or to the NLRI so that we can differentiate it further down the path, right? Or in these other autonomous systems, specifically AS400 and AS900. So here we go. Neighbor 209.165.45.4, default originate, route map, default 2. And I think I may have do show, let me do show run section BGP. Did I not type in, what did I say? 45.4, and that is, let me make sure we don't have a typo here. DEFAULT route map, default originate 209.165. Oh, my apologies. I need to, need to make sure we get into global config, router BGP 567. I wasn't in the address family IPv4 unicast. Wasn't in the address family configuration section there. So here we go. Neighbor 209.165.45.4, default originate, route map, default 2. So now let's scurry over to router 4 here, and my guess is we're probably going to have to give router 4 a jump start. So we're going to say show IP BGP. And you can see that, well, yeah, and this is where the communities become critical, right? So when you look at this, you say to yourself, well, hold on a second. How do I know if this is the default route that was original or locally originated using the default information originate command, or was this the default route that was originating using the neighbor default originate command? It's kind of difficult to tell there. So the tag becomes critical, or I should say the community that we've labeled it with becomes critical. You can see here it says community 1. Now, it's probably because I haven't refreshed the outbound advertisements. In fact, let's take one last look at show IP route. And, well, actually, 3 seconds. So while I was talking, I will bet you the community string is now different when we do that. And take a look at that. So I just mistimed it. So this is what I was referring to earlier. So it looks like the BGP update message was finally received by router 4. And in that update message, we have a default route. But take a look. It's labeled with community 2. And we know the only way that that would be possible is if it is installed, the default route, that on router 5, from router 5's perspective, it was locally originated at step 3 of the BGP best path selection algorithm. Step 3 says locally originated is better than external, or something not locally originated, not generated from the IGP. And then we drill down with the default routes. where we see right here that the neighbor default originate statement is in fact preferred over the default information originate statement, because we set it on, put the route map on router 4 to tag it with community 2. And you can see right there it was tagged with community 2, and this is what I commented on earlier, is really if we didn't label it or tag it with community 2, the only thing that I could use to even get kind of close to seeing that, hey, wait a second, it's picked up a new default route, is right here. And you can see it had been 3 seconds. And it was 3 seconds from when I was talking about it here to where I ran that command that the update message had been received, and we have now installed the default route with a community tag of 2. And that is because on router 5 looked at the locally originated versions of the default route that it currently has. And there are 2. One with the default information originate, the other with the neighbor default originate. And this is where in step 3, in sort of that sub-step for default routing information, router 5 said, I've got 2 choices here of locally originated default routes. And per the text, I'll pull the text back up, we have now conclusively shown that this is true. In decreasing preference, default originate is preferred over default information originate. But now what we're going to do is we're going to address the origination of a default route using the network command. And remember, we set that neighbor default originate is on a per neighbor basis. So over here on router 9, if I were to say show IP BGP, you can see that router 9 is still, has his default route is still labeled with community 1, because we didn't put a more specific or more preferred neighbor default originate statement on router 5 in the BGP configuration section. So he's still getting that default information originate default route. But on router 4, it is more preferred when it's on a per neighbor basis. So now let's mix things up even further here. Let's go ahead and say network quad zeros mask, whoops, get that 9 out of there, mask quad 0, and guess what? We can apply a route map. Extremely convenient so that we can differentiate when we're looking at the eBGP neighbors in this case, which of the default routes router 5 has selected as quote unquote the best to advertise to these eBGP peers. So now we're going to have a third and final locally originated default route from which router 5 is going to have to, at step 3, make a determination as to which one is going to be best. And so this would be default 3, simply meaning that it's going to have a community label of 3. So I say network 0.0.0.0, and let's quickly move over to router 4 here. And we'll say show IP BGP for the quad zeros. And you can see it still has community 2. What about router 9? Show IP BGP, the quad zeros, and take a look at what has happened. Community 3. So router 4 never changed its community. The community is still 2. So let's make sure we're not just, missing an update here. So clear IP BGP star inbound. I'm going to come over to router 5. We're going to do clear IP BGP star out, and I'll even do star in, right? Let's come back to router 4. We'll do out as well, even though it's not going to be outbound is where it's receiving it, but I'll do it just clean slate. And let's say show IP BGP quad zeros. It is still community 2. Then we come over here to router 9. Show IP BGP, show IP BGP quad zeros. And the community is 3. So in the context, and we'll step back here to our initial drawing. So in the context of step 3, when we're comparing, is the information locally originated or not? Remember, there's sort of two subcategories. There's A, which is for default routing information, and B, which is for non-default routes. So we have just exhausted all of the default route approaches that can be taken. We looked at default originate, and we saw that this is the preferred method. And we just saw that because router 4 is still preferring the community label, or the default route that we labeled with a community label of 2. And that was that specific neighbor statement that withstood the storm of both the network statement and the default information originate. Now to the network statement, which we did last, which was our community label of 3. We saw that on router 9, that when we originated the network quad 0 statement and labeled it with community 3, that when we activated that on router 9, which was originally getting from router 5 the default route that was generated with the default information originate command that was labeled with label 1, that disappeared, and that this network statement default route was inserted into the BGP local rib. And so again, it's not to say that within the context of the text we looked at earlier that's wrong. It could have been, again, at the time that the network statement origination wasn't there, or it just simply wasn't accounted for. So let's clear the screen here. Now what we're going to do is we're going to address the locally originated non-default routes. And again, what step 3 is not doing, it's not doing a comparison of the origin codes or origin types, right? That's step 5. What we're saying here is on the router, if it's locally originated, that takes precedence. And then if there are multiple local origination methods used, this is going to be the priority for default routes, and now we're looking at the priority for non-default routes. So let me clear the screen here, and this is pretty straightforward, right? And let's get back to this. So let's go to the command line, and again, when we're talking about local origination, and I can do this all on router 5. So what I'm going to do is I'm going to say interface loopback 55, IP address 55, 55, 55, 55, and we're going to make this a /32, is that if I go ahead and we'll set this up, do show IP interface brief, let's make sure. All right, so there's our loopback 55, so we're set up. So if I originate that with a network statement and a redistribute statement, which one is going to be preferred? So let's go into router BGP 567, and I'm simply going to say address family IPv4 unicast, and then we'll say network 55, 55, 55, 55 with a mask of a /32. So I'm going to come all the way up here to router 1, who's at the top of our topology, and let's say show IP BGP and include 55, and there it is. And you can see, and we can tell right here that it was originated with a network statement because it has the lowercase I in the origin code. Now again, we are not comparing origin codes here on router 1. That's not what we're doing, right? I'm just saying that we can identify it with the origin code, and this shows which one was selected on router 5 when it got advertised. Because we use that network statement, we see the origin code of an I. So let me come back down to router 5 here, and now let me say do show run section BGP, and I think, are we redistributing static? What are we redistributing? Yeah, we're redistributing static we have a route map. Now what I'm going to do is I'm just simply going to go ahead and say redistribute connected. Now 55, 55, 55, 55 is connected. It's a loop back, right? So it's seen as connected. So we'll come back up here to router 1 and we'll rerun the command. You can see it's still showing I. Well, let's give 5 a kick to make sure that do clear IP BGP star out. And I'll even do in just in case, but it's out is the one that we need. But let's just make sure, and we'll come up here and you can see that 55, 55, 55 is coming in with an origin code of I. So router 5 is clearly choosing the network statement. So let's remove that network statement. Let's see if that is in fact the case. So now there's an update message is going to go out with a withdraw, right? Notifying the neighbors to remove that specific prefix. Let me clear BGP star out. Let's come back up to router 1 and let's take a look. There we go. I was going to say it's possible that it hadn't made it to router 1, and I love when things like this happen right here, because take a look at that. Look at the timing was perfect. So we made the change. It hadn't propagated all the way to router 1 yet, but as soon as it did, now take a look. And so this is one way for us to tell on the remote router, right, the remote autonomous system, which locally originated route did router 5 choose to advertise. And we can clearly see the question mark indicates incomplete, and that's the result of a redistribute statement to get that routing information into BGP. So there's 2 forms right there of or I should say 2 forms. There are the first 2 preferences. You can clearly see that the network statement is preferred over the redistribute statement, and that it will be preferred over the aggregate address statement as well. And so that is pretty much going to wrap up step 3. And again, just to recap, because there's step 3, when we look at the document, it seems pretty clear cut, right? That the network is going to be preferred over the redistribute, is going to be preferred over the aggregate address. But what it doesn't mention here in step 3, it doesn't talk about default routes that are locally originated. And it doesn't go into much detail. So I wanted to make sure that we covered that as well. So again, step 3, what is it about? It's all about, and it's a simple question, is it locally originated or not? If it is, it's preferred. And then the next question is, well, are there multiple locally originated routes that I need to evaluate? If the answer is yes, you now know how to walk through that. If the answer is no, then the locally originated wins, right? Whichever one you have wins over that external source. And remember, don't confuse step 3 with step 5, because step 5 is going to be looking at the origin code, but from the point of view of remote routers, right? So autonomous systems where they're receiving multiple NLRI or multiple routes that are generated from different sources on different autonomous systems. Step 3 is very simple. Is it locally originated? So in other words, was the route learned from an IGP on this router? If it was, that's preferred. And then you break yourself, and then you take your next step. If you've got multiple originations, the network command has been used, the redistribute command has been used, maybe the aggregate address command has been used, then you know the preference between those. And with the default route, you know the preference there. And that's a critical one because, again, there's not much documentation that discusses, okay, well, I am locally originating the route. I'm going to use the default originate for one neighbor. I'm going to use the default information originate for another neighbor. And then, well, what's going to happen if I then use the network statement with the quad zeros? All right. Well, I appreciate you watching. I hope that this has really solidified your understanding of that third step and what it means when it says locally originated, and the two separate paths that we kind of have to go down when we're dealing with the local origination of default routes and non-default routes. All right, enjoy the rest of your weekend, and thanks for watching.